Hello, this is Mary Mack. I am the Executive Director at ACED, the Association of Certified eDiscovery Specialists, and we are pleased to bring you a blockbuster webinar today. We are global. We have many participants in the Netherlands for this particular session, and it's entitled Artificial Intelligence in eDiscovery, Going Way Beyond TAR and Predictive Coding. And our participants today include the founder and Chief Strategy Officer of ZyLAB. ZyLAB has been a platinum sponsor of ACEDS for a very long time. We're grateful for Jan, your participation, and among other things, Jan is the Extraordinary Chair in Text Mining from the Department of Knowledge Engineering at the University of Maastricht. And with him, we have Luc van Daele. He is the owner and founder of Legadex, and prior to that, he was head of legal affairs for Endemol and senior legal counsel with Sarah Lee. Also joining Jan and Luc is Harm Bavinck, and he is the managing director of Effacts software from Wolters-Kluwer, and he hails from the left coast of the United States, or doesn't not from there, but works with our friends over there at Codex, and so quite steeped in legal and advanced technology. So I'm going to look forward to a presentation that addresses not only TAR but artificial intelligence. And Jan will be using some slides that have some product on it to illustrate an educational point in the webinar. So that's what you'll be seeing there. And without further ado, Jan, will you take it over?
Yes, thank you, Mary, and thanks again for allowing us to present this webinar. It's a really exciting topic. Artificial intelligence has been something I've been working on since 1986, but for many years I didn't even dare to use the name or the phrase of artificial intelligence because the results were not that good, and I was always afraid people wouldn't take us serious anymore if we start talking about artificial intelligence. But a lot of things have changed, and there's a big hype right now in artificial intelligence, especially in the legal community, and that's caused because of some extraordinary results that we've seen, and I'm very happy to talk about this topic today. So first, we're going to talk a little bit about the trouble with eDiscovery and how artificial intelligence can help. I will give a couple of examples of artificial intelligence techniques that are already included in our products, at least for many years. Then what's also very important is that this kind of technology needs to be validated. It needs to be made defensible, and we'll show you how we can do that. And then together with me are Luc and Harm, and they are using the ZyLAB technology in their business to do very specific legal use cases in the field of contract discovery and contract management on the one hand, and M&A support and setting up virtual data rooms on the other hand. So that's our agenda for today. We do have quite some slides, but we will definitely keep within the hour. So the trouble with eDiscovery, well, I think we all know this, there's just too much data, there's not enough time, there's multiple sources, it's unstructured, and it's hard to search and to analyze. We can no longer do this with just human efforts. We need machines to fight the machines. All this data is generated by machines, and we need to automate part of the process. Of course, like I said, we need to validate the quality of the automation, but without automation, we will lose this battle from the machines. So, how can artificial intelligence help? Now, artificial intelligence techniques are used to learn, to identify and classify specific document categories, and to search for relevant information in these documents. And this is kind of what all these techniques do. They recognize something, they do something with it, and then they present it to the user in such a way that it makes the work of the user easier. And in general, what we see is that in any field where we finally figure out how it works, which has been subject of research in artificial intelligence, at the end of the day, these computers will be faster, more reliable, more consistent, and of higher quality. And that's something we will continue to see in this field. What's also very interesting is that in almost all cases, we demand higher quality from these computers than we do from humans, because in the cases I will show you, and there's also a lot of publications about this, computers consistently outperform humans, and even then, yeah, people are still doubting the quality of these algorithms, where often they don't ask, or they do not demand the same kind of high level of quality from their human reviewers or performance. So what is artificial intelligence? Now, there's a lot of different keywords. If you look up these word clouds on the web, it's about big data, artificial intelligence, cyberspace, cyborgs, robots, cognitive science. So there's a lot of different things. Now, in the field of eDiscovery and in the legal fields where we use artificial intelligence, we're not going to talk about consciousness and intuition. That's what Hollywood does. And there's a lot of great movies, and I always enjoy them, about robots getting consciousness, or all kind of complex relationships between robots and humans. But if you look at what is the state of the art of artificial intelligence in the more text-oriented, data-oriented, information-oriented legal kind of applications, it's intelligent search, it's information classification, it's knowledge representation. It's also the transfer of knowledge from one computer to the other. And of course, it's machine learning. And you also need to understand that what's artificial intelligence today may very well not be it in a few years from now. To give you an example, OCR, optical character recognition, was considered to be artificial intelligence at the end of the 80s. Now it's no longer. It's just an algorithm we truly understand and that works, and we no longer consider this to be artificial intelligence. There's a lot of other things that we do consider to be artificial intelligence. That's because we still can't reliably solve these problems. Speech recognition, slowly getting there. Communicating with computers, driving a car, certain other robotic applications. So these are still very hot fields of research in artificial intelligence. Now, going back in history, I want to talk about 3 breakthroughs, and I got these slides from Professor Jaap van Heerik from the University of Leiden, who's been working in the field of artificial intelligence even longer than I have, and who was also involved in computer chess and in many other projects, and also recently in the Go project. Now, one of the first breakthroughs we all remember was in 1997 when Kasparov was beaten by IBM's Deep Blue. This was a very interesting project, because Deep Blue just used brute force computer power, and actually Deep Blue used more computer power at that moment in time than the computers used that Google DeepMind had. So there was more megaflops in these Deep Blue computers, and they used it to really search almost extensively all the different possibilities. And Kasparov was very upset, as you may remember, when he was beaten, because he said, you know, there's no emotion, there's no intuition in this computer. It just, you know, it plays like a robot, and he never really talked about his defeat afterwards. Now, the game of chess was solved, as we call it in artificial intelligence, and we went on to other challenges. Now, the other breakthrough just 5 years ago was, of course, IBM's Watson, where in the game of Jeopardy, Watson beat the 2 best candidates that were around. Now, Watson, the way how it worked It was really a very large memory system. Everything we knew was stored in Watson, and on Watson there were different types of techniques were integrated with Watson. There was a lot of engineering, from the top of my head, about 7 years of engineering from the first version, or at least 5, I think, from 2007 to 2011, before Jeopardy became the champion, or Watson became Jeopardy champion. And a lot of information or a lot of knowledge that's very intuitive to us people had to be programmed explicitly into Watson before it could win Jeopardy. And one of them was, for instance, that in one of the cases Jeopardy lost because it gave exactly the same answer twice in different rounds of the game, and that was because it didn't learn that you should not give the same wrong answer twice. And so after these type of errors, each of them have to be fixed, and that's how Watson became intelligent, and that's how Watson did it. Now, really the biggest breakthrough is what we've seen recently. In October 2015, Google DeepMind beat the European champion in Go, and Go is a game which is much more complex than chess. All the different positions on the board that are possible with Go count higher than all the molecules or all the atoms that exist in the entire universe. So it's much more complex than chess. And the way how this was solved by Google is very interesting. They use traditional algorithms, traditional search algorithms from artificial intelligence, Monte Carlo tree search to be more specific. And they built 3 neural networks, 3 models, computer models that are modeled the same way as our brains are modeled, with neurons and synapses. And one neural network should tell the algorithm if it needs to go search deeper, so if it's on the right track. The other neural network needed to tell the algorithm if it had to search broader, so look for more intuition and creativity, and try different directions. And then there was a third neural network which had to evaluate how well my current and future positions were. And this was implemented kind of in the same way as a retina in the eye was implemented. And that's what neural networks are very good at. They're very good in visual recognition. So Google translated the problem of Go partly into a visual problem. Now, by doing this, initially the system was trained with 5,000 games of Go masters around the world, and it did pretty well, but it didn't beat the European champions. Now, what was the really big innovation here is that instead of engineering the system for 5 years, like had to be done in Watson, and explicitly put all the knowledge in manually, the DeepMind team started to have the computer play against itself, and it played millions and millions of games against itself, and each time it became better because it was very simple. It was a very simple loss function. If you won, you did something right. If you lost, you did something wrong. And after the European champion was beaten with 5-0, the big next challenge was to beat the world champion, who was clearly much better. And in this case, I think altogether, from the top of my head, it was either 20 or 30 million games were played the computer against itself, and it beat the world champion by 4-1. Now, after this, Google let the computer play even more games against itself. It became better and better and better, and now it strongly outperforms any human behavior on the planet with respect to Go. And the big difference is that in this case the algorithm trained itself, and then the world champion Go, he wasn't as upset as Kasparov was. He actually felt that sometimes the computer showed something like intuition or creativity. And right now, professional Go players are analyzing the games that DeepMind's playing in order to find different variations on teams and to become better players. And this is a really interesting breakthrough. Now, if we look at a little bit back down to earth, how artificial intelligence can help us in eDiscovery. Now, unfortunately, we haven't been able to try to translate the problem of eDiscovery into a win-loss, a very simple win-loss function. So we can use, we can generate our own information. But if anybody has any ideas, I'm really open for this. Well, what we see in artificial intelligence and eDiscovery, we see a number of techniques that are used and considered to be artificial intelligence. Of course, it's the machine learning, especially in the technology-assisted review. It's natural language processing, understanding the nuances and the finesses of language, data and text mining, big data analysis, concept search, topic modeling, clustering, but also search in audio, machine translation. They're all part of artificial intelligence research. And in all of these fields, we do not yet perform as good as humans. Sometimes we come close in certain specific domains. But in the next years, we'll see that computers will consistently increase in performance, and eventually, in many of these different tasks, computers will outperform human beings. Now, within ZyLAB, we've been using this technology for many years, and we use all of the above what's here in our products. I just want to show you here as a couple of examples, integrated machine translation. The translations are not legally submissible. They use statistical machine learning and algorithms. So the algorithms are trained by showing the system examples of English and Chinese texts where the translations are synchronized. So every sentence you have in English, you also have the exact translation in Chinese. And these statistical algorithms, they learn and then they can translate these texts. This is the same technology that's used by Google Translate and by Bing. And the more data we will get, the more of these parallel corpora of translations we will get, the better we will see that machine learning or machine translation will become. In the audio search, this is something we've built in our product for a long time. Instead of transcribing the sound component into text, what we do is we only recognize certain sound decks or certain vowels, and there's for each language, like American English has about 66 of these components. We recognize these 66 components, and then whenever we want to search for a keyword, we translate these words also into the different vowels and the syllables, and then we do a kind of a fuzzy match between these two, and this allows us to, with 60, 70, 80%, depending on the quality of the recording, proper retrieval of certain recordings. Even if the quality is pretty bad, it still works very well, and even it works very well on names or on product names or city names or geolocation or individual names it has never seen before. So this is all based on deep learning and on statistical algorithms, the same algorithms that are used by DeepMind, and they're trained with very large examples of recordings from different humans, different dialects, different languages, together with their phonetic representation. And then, the more data you get, the better the algorithms are. And there's one saying we have in artificial intelligence is that the only good data is more data. Text mining is something that has taken a very fast route to success. Entity extraction, recognizing semantic categories is something we can do very well, but we can also recognize problems. We can recognize sentiments. We can recognize requests. And this uses not only statistics, it also uses linguistic knowledge. It knows where a named entity starts and ends in a sentence. It knows if it's a plural or a singular entity. It knows whether it's a conjunction of different entities, so you have to deal with two entities, or if it's just one very large complex entity. A great example is, for instance, the State University of New York. That's just one entity, but computers that don't understand the finesses of the natural language will think it's, well, it's a university, it's the city of New York, and maybe it's also the state of New York. So they will not recognize it properly. Now, with the right linguistic tools, you can actually do a much better recognition. Now, where this will lead to is that if you have a lot of data and you need to analyze or review this data, artificial intelligence can help you to organize, pre-order this data along many different dimensions. So you can use dimensions of entities, email, senders, but also requests, sentiments, and just whatever the fidelity is that you're looking for, you can use it. And we all know that organized data is easier accessible by humans than non-organized, unstructured data. And this will lead to more efficiency in the review. It will be a huge review accelerator. If you kind of know what you have the total overview, and you can zoom in on all these different facets, and you can change your facets. It's like virtual facets. You can change them any way, in a way you want. In the world of TAR that we all are very, very familiar with in the field of eDiscovery and ASATs, we've seen different blends of TAR. There's the TAR based on full text queries, which is not really considered to be TAR, but it allows you to classify documents by just using queries. It has some advantages. You can reuse it, and every lawyer can define a query. So you don't need a very expensive data scientist to do this. You don't need to understand complex artificial intelligence machine learning algorithms. There's also the rules-based natural language processing, where you're going to look at different words, subjects, objects, predicates, verb combinations, different inflections. Also something which can be understood very well by people that have a non-mathematical education. Also very powerful, can be reused, but the disadvantage is that you have to engineer it in advance, and that can take a lot of time. And this is kind of where the majority of what Watson does consists of. Now, the more advanced artificial intelligence and machine learning that we've all seen is the machine learning where you take a number of example documents and the computer automatically derives a mathematical model to be able to classify other documents that are similar. But the way how we see that our users use TAR is to automatically classify responsive and non-responsive documents, but also to maximize the recall. The TAR allows you to find 80% of all of responding documents very quickly. We see that TAR is used more and more in search applications, and I'll show you a graph on that. It saves, of course, tremendously, and it allows people that don't have very deep or very well-developed search skills to also find as many relevant documents as possible and move up as fast as possible to about 80% of recall. Now, why do I use 80%? 80% recall and precision also is kind of considered to be human performance. Everything over 80% is subjective. So if you can do something at 80% quality, then you are performing at the human level. So that's what we're trying to aim in this field. It also allows you to find without knowing exactly what you're looking for. Now, we've been able to do this for many years. So we had traditional Boolean search, which gives us a certain recall percentage. There's a famous research from Blair and Marin in '86, which showed that despite the fact that lawyers thought they found 80%, they only found 20%. And these lawyers only could use traditional Boolean search. Over the years, we developed more advanced search, fuzzy search, incomplete searching, wildcard search, quorum search, proximity search. We used various schemes of relevance ranking. We could also extract metadata and use metadata for search. And each of these techniques helped us to increase our recall. At the end of the day, we could do OCR and bitmaps, visual classification, text mining, audio search, machine translation. And it is this machine learning, the automatic document classification, that helps us to get the last piece of the puzzle. But if you are not if you don't have all these other techniques, if you don't have all these, you don't know how to define very complex queries or Boolean queries, then you can already start using this machine learning just after the traditional Boolean search. And and this is something that we see in the current TAR protocols by finding a relevant document set by using just search and some of these techniques. As soon as you found like 50 or 100 documents, you can build a classifier. You can then validate the classifier, and then if it's good enough, match it against the other documents and return your best matching documents until you reach, after a couple of cycles, stop condition, which could be that you surpass certain positional recall on your training and test set or on your return set, and then you stop. This is what we did here in this graph with the 800,000 Reuters data set. And what you see here is that in the category sports, which is the second one here, which is 35,000 documents, only after reviewing about 32,000 documents manually, 90% of all the articles is found. And this is, of course, much more efficient than having to review the entire corpus. Now, having said that, you see that this graph here, each dot is actually an iteration, is very steep. So already after just reviewing 500 documents, we could have let the algorithm learn the rest and classify the rest automatically by itself without having to do any more additional reviews. We just did the reviews here in order to make our point and make sure that we actually do really find 90%. But even then, it's much more efficient than having to review the whole 800,000 documents. Civil war in the Reuters data set is a little bit more complex. It uses different words, and you see that it goes just as fast, and then suddenly it kind of slows down a little bit. This is the behavior we see also with other more complex topics. The Reuters data set is a data set that's completely manually annotated, so each document has been reviewed by users, what the topics are that are discussed, and then so you can do these kind of simulations very quickly. But the results are really impressive. It's in the sports category. You know, the number of reviews TAR has to do are just a fraction of what we have to do with the manual review. In the awards, it's similar. Now, this is of course something we all know. This is also why we've all embraced TAR and predictive coding in our field of industry. And yeah, we try to make it as easy as possible for the user, where we do not just show the TAR as a very complex process, but we actually built this in the review platform, where what we do is as soon as you have a certain number of documents, we'll automatically start building classifiers in the background and return better documents to the user. What we've done recently is we've been expanding this, because finding relevant documents using concept search and topic modeling is actually a better idea than searching documents with Boolean keywords. One of the things that we built, and this is still in R&D, but will be in our product very soon, is that we created these topic stream. And we also used the Reuters data set here. And we classified all the documents into different periods. I think it was like a number of weeks. And what you see here is the topics that were automatically derived from 8 months of Reuters news. And you see different topics here. You see the whole issue in Syria. You see the Israel-Palestinian issues like going on for almost a whole year. There's here Iran with the negotiations about the nuclear deal. And then here's something very interesting. What you see here is the invasion in Ukraine. And here you see MH17 being shut down over the Ukraine. And you see the whole development of the news here in what we call topic rivers. Now, these topic rivers are a great way to start your machine learning. And this is how we're trying to combine different areas of artificial intelligence in order to make it easier for the user and even help them if they have no idea what they're looking for. Now, like I said, we demand higher quality from computers than we do from humans. So we need to validate this. And this is something that you need to build in, or you need to have a validation algorithm, not only for TAR, but also for any type of artificial intelligence technology that you use, because you want to make sure that it's done right. Okay, so that's very quickly a lot of slides, a lot of information. I don't know if you want to ask any questions right now, Mary, or we just continue?
Well, yeah, I think we can just continue. But one question was, is the Reuters set a public set? Is that available for others?
Available for download. It's the RCV1 and RCV2 sets, and you can download them. Yeah.
Okay, and people could contact you to get the link to do that, or?
Yeah, sure. Yeah. Okay. You just Google it. If you Google the Reuters RCV2, you immediately find the download link.
Okay, very good.
Yeah.
Thank you.
Okay, now I would like to hand over to Harm. Harm, are you already online?
Yes, Jan, I'm online.
You solved all the technical problems. And,
I solved the technical problems with artificial intelligence. Thank you.
Yeah. So I want to give you the floor. I'm going to show your first slide.
Okay.
And you're going to talk about contract management and how to use artificial intelligence to do the document intake for contract management systems, right?
Yeah, Jan, thank you. Very introduction to artificial intelligence. My background is in legal, so it's quite technical for me, but I start to learn more and more on e-discovery and the way we could use technology in our daily practice as a lawyer. My background is I've been a general counsel for several companies in the Netherlands, and yeah, I used a database to collect all the legal information of these companies, and that database is evolved into a contract management system that is sold to companies in Europe and in the United States as a contract management repository. And the use case of this system is that we help clients collect, extract, and manage all the contracts of an organization. And this system is, yeah, we call it a legal bookkeeping system, and it helps general counsel and people working in the legal team to have immediate access to yeah, relevant documents, but also to create reports on all kind of legal information related to the contracts, like expiration dates, overviews of the number of contracts per vendor or customer. We can do reports on yeah, specific topics in the agreements, like change of control clauses or specific guarantees. So it's a very useful tool for general counsel to stay on top of all the relevant legal information. And this system is yeah, used now for more than 10 years. We have been helping companies with the onboarding of our tool, and yeah, we work with legal service providers to do a lot of the legal extraction work. And since a year, we work with ZyLAB to automate a part of the work. So if Jan, you can click on the next slide, I can show you how we normally do the work with the help of legal professionals. They review a document and they extract all the key data points out of this document manually. So on the left you have an example of a contract, and on the right there is a form where a legal professional, like a paralegal or a legal admin, is able to extract the key data points like the effective date, the expiration date, the change of control clause. And this work has been done manually for years. So we have been helping our clients with the onboarding of all the contracts into our yes, centralized repository with the help of yeah, human resources. And with the help of the technology of ZyLAB, we are trying to make these human resources more efficient. And the concept is that we can use the artificial intelligence Jan explained during his presentation in the use case of contract management. And there are two specific areas where we use the ZyLAB technology. And one is that within most of the companies we work for, it's very difficult to identify the executed documents. So it's the first use cases that we help our clients with the technology of ZyLAB to identify out of a huge set of data the exact contracts they need to manage. So it's a first step in the onboarding of a new client that we need to help the client identify all the relevant documents. And by using the AI technology of ZyLAB, we can easily identify the relevant documents, and we can also identify the documents that are not relevant enough to be part of the administration within our contract management system. So that's a huge time saver, and with the help of the artificial intelligence, the paralegal, the legal admin, or the legal team of the organization is able to save a lot of money by being more efficient in the identification of the documentation. That's a very important use case for us, and the second is presented on this slide, and this is where the artificial intelligence of ZyLAB comes in extracting data points automatically. So by using the algorithms Jan explained during his presentation, we are able to identify the title of the agreements automatically. So if you have a set of contracts, the software is able to classify these contracts automatically by, for example, creating a subset of lease agreements, loan agreements, and other relevant classifications. So that's a very important task for the artificial intelligence, because you can also organize the work by classification of the different agreement types, and it is a huge time saver for the people that need to do the work on extracting the documentation and review all the contracts of the organization. And the next step in using the artificial intelligence is, of course, that we are able to extract other data points like the names of the companies, the relevant dates in the agreements. And we are working on additional data points we would like to extract automatically for our customers. And in some use cases, we are able to extract, for example, the limitation of liability in all the documents that are stored in our contract management system. But what we foresee in the future is that with the use of the ZyLAB technology, we will build up a library of different algorithms that will help our customer base identifying the key relevant data points in each of these agreements. And the progress we make is a huge time saver for our customers. So then the next step, of course, by doing all the extraction and the identification of the data points, we help our customers to basically structure the data that is stored in the documents in a way that it will automatically generate the required reports and statistics that are needed for the transactional work as a legal counsel within a company. And these dashboards are based on all the information that is extracted with the help of ZyLAB out of these documents that are stored in our contract management system.
Okay.
Any questions, Jan?
Yeah. Thank you, Harm.
Okay.
For a great overview. Luc, I want to give it over to you. And I see that you're still on mute. Hello.
Yeah, I think he's still on mute as well. There we go.
Yeah, am I loud and clear?
Yeah.
Now you are.
All right, thank you so much. Just a quick introduction. I think we heard a lot about artificial intelligence and use of data analytics, for example. I think going back to history, my own wake-up call about the use of technology and artificial intelligence was in fact in the year 2001. When I had just become general counsel of the Dutch company that brought the programs like Big Brother and Deal or No Deal into the US market. we were immediately faced with a multi-million dollar lawsuit with an extensive eDiscovery. I think that was really the moment when the importance and the development of artificial intelligence became clear to me. I think if we now look at the years afterwards and what has been developed since then, I mean, that's of course fantastic. We have, as Harm started his business, which was later became part of Wolters-Kluwer. I started my business after, let's say, being the general counsel of this company in 2001. And the whole focus of our company, Legadex, which you may qualify as an alternative legal services provider in the Benelux, is focus on workflow and use of technology. And what we see is that the use of artificial intelligence technology, let's say, especially the last couple of years, takes a tremendous approach. I mean, there's a lot more to it than just eDiscovery and the more traditional forms of data analysis. What our challenge is with ZyLAB is to explore additional ways of using the technology, and I think we have been able to reach quite a number of successes with that. What I would like to show today, Harm has already gone into more detail about the contract analysis. What I would like to show you in a little bit more detail is how we use the technology in M&A and in larger projects. I mean, how we look at handling documentation and handling information flows in M&A and in projects is reflected in this sheet. I mean, we start conceptually, we start at, let's say, the collection and processing phase of documentation. Then we use technology to categorize it. We use this technology to be able to search within documents in, let's say, using all combinations of technology as Jan has explained. We try to determine which type of documentation has a certain relevance and is connected to what. And we try to build reporting, a clear, concise reporting based on a document flow. I mean, that's how we look at it, in fact, in a very systematic and conceptual way. If we look at M&A by itself, I mean, of course, we see that the typical reasons why data technology must be used these days. It's a matter of cost. It's a matter of lack of opportunities. It's, let's say, not missing any key information. It's a matter of risks. What we try to do is, apart from the traditional usage, develop the new usage in categorizing the data, combining the data, due diligence, but for example also redacting certain documentation. For example, in situations where certain elements of documentation need to remain confidential. That's also, let's say, a way of using the software, which is not very traditional, but where you can really sort of use the technology for in new ways. It's a matter of time reduction. We use the TAR solutions a lot in our own work. It's really creating efficiency and not losing time. So it's a matter of creating transparency and efficiency for our clients. We also work a lot with law firms, more and more. And then, of course, if we prepare certain sets of documentation for them, for example, make them ready for review and make them ready for due diligence purposes, of course they want to understand how the set of documents is put together, and based on which type of searches we have come to certain conclusions. So then you can actually build a factual basis for reliance, and that's typically something that law firms are asking for. And then you get to the point, okay, how can technology help? It's not a sort of 100% replacement of the human work, but it really can substantially help when you classify documentation and when you can make documentation searchable. I mean, you can also attach a workflow and a work process to it. I think there's still a lot more that can be done with it, and I think there's also a lot going on in the market in that respect.
Next slide. Or
yeah, next slide. Yeah, there we go. One example is we do a lot of work in virtual data rooms. I mean, what helps us tremendously is, let's say, the classification function. I mean, if you look at a data room, of course, there are many, many topics, which all, at the end of the day, need to be put in a certain structure. What helps us in using, let's say, the categorizing possibilities of the software is to put certain topics under a certain heading, and also to check whether information is put at the right place, or whether we are missing any information. So that's really a major efficiency use of the technology, which helps a lot in speed, but also in making documentation transparent, because it's not just categorizing and putting it in the right folder, but it's also making it ready for due diligence. And if certainly, I mean, at seller side, certainly if the seller side and advisors of the seller side are able in a platform like ZyLAB with the right queries and the search capabilities to have a better understanding of their own information, it helps a lot also in due diligence preparation, and also in anticipating what needs to come in the M&A negotiations, and how reps and warranties need to be anticipated, and what the factual situation is. So I mean, there's really a lot to it in the preparation phase and also in the due diligence phase.
An example? Or?
I think we see a lot of this usage in contract review, but besides that, of course, there's also a lot of classification possibility in other documentation. This example is about financial statements. How do you find financial statements? How do you find copies? How do you find the different versions? This is just an example of a non-contract document, but it could be done with any document. And the good thing in, let's say, the usage of ZyLAB is that it has a sort of open structure by which it can not only be applied to contracts, but basically to any type of contract. And that's what we like about the possibilities. That's one thing. And the other thing is that what we see in the market, much of the legal software and analysis software is really focused on English language. With ZyLAB, you can also pretty easily, for example, use it for Dutch or French language projects. Doesn't really matter if you find the right scoping to it. I mean, you have a very broad span of use. So that's also what we like about it. This is how let's say underlying search queries come out in documentation. So we're able to sort of click through to the underlying documentation, also for due diligence purposes. This is an example about financial statements. This is an example about the review platform. It's a bit difficult to really show how the review platform works, but I assume many of you will work with review platforms, so will know, let's say, the system, how it works. That's also how we use it. And one other example is auto-redaction. In preparing a VDR, certain information needs to be redacted. The use of the platform can also help tremendously to speed up that process, because this job can, of course, be very cumbersome and take a lot of time. And this is also a way in which the software can help us how we do it in practice.
Yeah, we have a question about the M&A context, and is there an assumption that you need to export documents from the virtual data room and then import them into the tool?
Yeah, that's a very good question. The way we use it most of the time is seller side. So what we do typically is use ZyLAB in our preparation of the VDR. So then it is from the ZyLAB platform put into a VDR and a VDR structure. The other way around is, that's an interesting question for the future, is a company that is put up for sale with its information in a VDR. Is it willing in the divestment phase? Is it willing to make the documentation available for and for due diligence review? Most of the time, at this point in time, companies are not, and they simply take the approach, okay, well, this is our VDR, you can have a look at it with all your advisors, and that's it. My expectation is that this may change in the future, because, of course, the possibility is there to export these docs from a VDR structure to a search platform like ZyLAB, and that's, of course, very interesting to a potential buyer. Question is, okay, is a seller willing to do that? Because you cannot automatically log on to a VDR because they have certain protections in place. Yeah. So they need agreement between the parties to do so, but then, of course, it opens up very interesting opportunities.
Yeah, also if you want to analyze the reps and warranties after a deal, that's another interesting use case.
Yeah.
But most advantage is that you can identify and try to resolve problems before you put documents in a data room, and that's already very important when you want to when you have a time-sensitive deal, and if you know where the problems are, you can solve them before the other parties make an issue of it, and you can try to close the deal in a shorter time frame. And especially when in the case of fundraising or divesting, this is a really huge advantage.
Yeah, that's right, Jan. I mean, you can be on the seller side, you can be much more in control of your own information.
Yeah. Okay. Does it answer the question, Mary?
That does answer the question, and we've got another question about validating the systems. Would you suggest validating the software with a known data set like the Reuters set, and that would be sufficient validation, or do you?
That would be a good start. That would be a good start to get an idea of the quality of the algorithms, but you always have to validate it with human reviewers. You have to do a random sampling and validate the quality, whether it's auto-redaction or whether it's auto-classification or information extraction. In some cases, you may not need to validate it because it's just a search, or you just want to swim around in the data, and you don't need to disclose any data to a third party. But if there's a big risk that the other party will challenge what you did, then you absolutely need to validate it by random sampling and human review.
Very good. Very good. And the another question is, you had mentioned different languages. Is there something that needs to be done before different languages are able to be put into the algorithm, or is it an automatic thing with the artificial intelligence?
Yeah, that's a very good question. It depends. Some of these algorithms are totally language insensitive, and very little you need to do. Maybe for efficiency you need to do some optimizations, but these days computers can recognize languages very well, very easily, at 99.9% accuracy, and then you can use these different you can automatically do these different optimizations. But for like machine translation, of course, you need to have support. You need to have language pairs. For topic modeling, there's no real need. Not same for TAR. But if you want to analyze languages for linguistic purposes, yes, then it's absolutely, you need to have a parser, or you need to be able to recognize the language. And so something needs to happen in advance. If you do the rules-based, then everything is very language specific, and you cannot do that without understanding the language. So it depends on the different algorithms.
Okay, and another question, does ZyLAB have an API for import and export of files, and if so, what language is it in?
That's an interesting question. No, we don't have an API. I presume the question is related to our machine translation, but we don't have an API. It's just we just use this as part of our platform.
Okay, well, we've got quite a few folks on here with extreme learning and machine learning, as you might know from these questions. So I'll wrap up with a question because we're almost at the top of the hour. What I've seen here is an extension of eDiscovery software, or software that's traditionally used for eDiscovery, to move into the transactional side. And can you talk a little bit about how you approach attorneys on the transactional side to use this? Do you call it eDiscovery software? Do you call it something different? How does that work?
Part of this question, and then Luc can answer the rest. But what we see is that eDiscovery software has many different use cases. The technology that's used in eDiscovery is exactly the same technology that's used in the same workflow almost that's used in FOIA and public records requests. There's differences in workflow details. There's difference in the kind of information people are looking for. There's difference in language. You know, a redaction is called an exemption, and there's some of these other small differences. Other use cases are search, internal investigations, also the same technology. And what we noticed is that transactional services, M&A related, like building up the virtual data room, is a use case where eDiscovery can really help. Related to M&A is also FCPA investigations or secondary requests when you want to get merger approval. All of these are use cases that are very, very similar in workflow and technology that can automate the process and increase productivity in this field. Now, Luc, can you answer how you approach lawyers in this part?
Yes. The way we approach lawyers is especially by explaining to them how we can prepare information for them, because for them it's difficult to find out how they can actually do this and how they do it efficiently. They are facing more and more pressure from their clients to work in a very efficient way and save cost. So that's our story to the law firms, is that they can use us to prepare their information and to do their work faster and they're informed. That's one answer. A specific answer in M&A is also that we have a couple of specific use cases, for example, in real estate. and the real estate divestment, where we sort of build the whole information file related to real estate. And I mean, most of the time, this is so document intensive that this is very hard for a law firm to do. So we can deal with that information and also huge volumes of information. Another one is in the banking world, where we use the technology in an M&A context. For example, to structure loan portfolios and put them, let's say, in a structured way, ready for sale. And then the law firm can do its due diligence, come to conclusions, but I mean, they know exactly what you're talking about when they give their advice or give their opinion. So that saves them a lot of time and effort. Is that an answer to the question?
It certainly is.
Yeah.
It certainly is. And so we want to be respectful of everybody's time. If there are unanswered questions, we'll send them over to the panelists for them to contact you, and then we'll also send out a PDF of the slides with a link to the recorded webinar. So I want to thank all of our panelists, including our cartoonist here. Are you speaking about attorneys here, Jan?
No, I'm not. No,
yeah. Okay, all right. But
with beards and yeah.
Yeah, so I thank all of you for your kind attention today, and I thank our panelists for a fantastic introduction and extension of artificial intelligence in the legal context. So thank you very much.
Thank you, Mary. Thank you.
We forgot to say there is a booklet called Artificial Intelligence for Your Daily Business, and you can get that by sending a request to Annelore Vanderlint, ANNELORE.VANDERLINT @ZyLAB.com. And that's a wrap. Thank you.
Thank you.
Thank you so much.